Today, we will venture into another interesting and useful topic, important in our daily life. But wait, I could hear the sound of a siren somewhere. Let's turn on the radio and find out what's going on.
Sa kasalukuyan ay merong nagaganap na sunog dito po sa Quezon City. Hanggang sa mga oras na ito, may mga iilang katao ang naroroon pa sa loob ng kani-kanilang tahanan at hindi makalabas. Malaki na po ang napipinsala ng sunog na sinasabing ang pinagmulan ay faulty wiring.
Tragedies like this happen almost every day, especially during the summer. As we heard over the radio, this particular fire was caused by faulty wiring. How did it start? Fellow teachers, this incident could have been prevented if everyone knew about electrical hazards and safety. Electricity brings countless benefits into our lives, but it can also bring damages if we don't know how to use it properly. In the home, if we don't have enough electrical outlets, we resort to using a multiple socket. This is a multiple socket. A multiple socket is an electrical device that allows several electrical appliances to be connected at the same time using one power outlet. At this point, we'd like to introduce our assistant, Mr. Santi Siliesa, who will assist us in our demonstrations. Take this example. A TV set is plugged into a multiple socket. All right. And because it is hot, we may also plug an electric fan into the same multiple socket. And if we want to watch a video, the VCR may also be plugged into the same multiple socket. Is it wise to do this? What do you think will happen if we keep on increasing the number of appliances connected to just one multiple socket? To answer this question, let us try to measure the amount of current in the wires using a multitester. Here is our multitester. With only the TV set on, our multitester here indicates a reading of 0.36 ampere. Suppose we plug the TV set and the electric fan. Let's plug the electric fan, Santi. So what will be our current? Our current will be 0.53 ampere. And with the VCR included, the amount of current in the wires is about 0.6 ampere. From here we can see that increasing the number of appliances connected to the same multiple socket would increase the total current. Why was there an increase in the total current? Previously, we have learned that for the same voltage, the current is big when the resistance is less. We will now determine the resistances of these appliances using a multitester. All right, Santi will again assist us in our tests here. All right, let's take the resistance of the TV set. We can see that the resistance of the TV set is about 28.1 ohms. Let's now measure the resistance of the TV set and the electric fan. Okay, let's read the multitester. It's about 25 ohms. Now, measuring the combined resistance of the three appliances, the TV set, the electric fan, and the VCR, give us a combined reading of... All right, so thank you very much, Santi, for your assistance. From here we can see the effect of having more devices connected in parallel to a multiple socket. As more devices are connected in parallel, the combined resistance of the circuit becomes very low. Hence, a large amount of current occur in the wires. There is always a limit to the amount of current the wires can safely carry. Wires carrying more than the safe amount of current are said to be overloaded. Safe amount of current means the maximum of current the wires could carry without overheating. Very large amount of current transfers too much heat. As a result, the cord's insulation may melt, and this may eventually cause fire. The same is true with plugging several electrical appliances into wall sockets that are connected to a single power circuit. If the appliances are made to operate at the same time, the total current in the circuit will also increase tremendously. As a result, overloading may occur. Welcome back, fellow teachers. Let's get on with our electrifying lesson. A while ago, we talked about overloading in circuits. Now, how can it be prevented? To prevent overloading in the circuit, fuses like this are connected in series along the electric wires. This is how a fuse looks like. Inside it is a piece of copper wire, and the wire is thin because it is designed to blow if the current in a given circuit becomes too high. This is intended as a protection against fire started by an overheated electrical circuit. If the current rises above the rated value of the fuse, the wires in the fuse will melt and break the circuit. The breaking of the circuit stops the current, hence it prevents the onset of fire. In the home, fuses are found in the panel board, in other parts of the house wiring, or in certain appliances. Nowadays, modern houses use circuit breakers like this in place of fuses. Circuit breakers are automatic switches, and they open if the current rises above a certain value, thus breaking the circuit. Often, the insulation that separates the wires in a circuit wears away and allows the wires to touch, like in this example here. When the exposed parts of the cord touch, like this, a new circuit is formed. This shortens the path of the circuit. One factor affecting the resistance of the wires in the circuit is the length of the wires. The shorter the wires, the lower the resistance becomes. In the event that resistance becomes very low, what effect will it produce? That is right. From Ohm's law and from what we have observed a while ago, there will be an immediate increase in the current through the wiring. The extremely large current would overheat the wires, possibly causing a fire. To understand this better, let us consider our setup here. Okay? When the switch is on, let's turn this on, you can see that the lamp lights up. Now, supposing I connect a short wire at these 2 points, at this point and at this point. What do you think will happen? Okay, watch closely. You see? The lamp goes out and the fuse wire melts. The fuse allows the lamp to light in the first place, but as soon as the current rises above its normal value, the fuse wire melts and the circuit is broken. The wire connected across the lamp is called a short circuit. It provides an easier route for the current than through the thin filament of the lamp. This is why the lamp goes out. Also, because the short circuit has a very low resistance, the current in the circuit rises and melts the fuse. The melting of the fuse also prevents the lamp from being damaged. All right, so let's consider that. Let's see if, all right, momentarily you can see that the lamp lights, and that means that it has been protected. So you see the fuse becomes your electrical protection. How do we determine the right fuse to be used for our appliances? To determine the right fuse to be used for our appliances, first, you must know the power and voltage ratings required by an electric appliance. Knowing this, you will be able to determine the current required by the unit from this relationship. Power divided by voltage is equal to the current. For instance, this flat iron here, it has a power rating equal to 1000 watts and voltage rating of 220 volts, and it uses a current equal to 4.5 amperes. Therefore, a 5 ampere fuse, like this one, would be suitable for this appliance, since a 4.5 ampere current will be able to pass through the thin wire, but will melt if the current is increased to 5 amperes or more. The fuse value should always be more than the actual current, but as close to it as possible. An appliance will still work with a fuse of large value, but it might not be safe. Putting in a fuse of higher rating may stop it from blowing, but it defeats the purpose, which is protection. If something goes wrong, the circuits could overheat and catch fire without the fuse blowing. That is why you should never replace a fuse with a thick wire or with a coin. The thick wire or the coin will not limit the current to a safe level. Houses have burned down because of this. Electric fires due to faulty wiring are mostly the outcomes of using a fuse of higher rating, or of using a wire of big diameter, or of using a coin instead of a fuse. Always remember that before the fuse is replaced with a suitable one, or before a circuit breaker is reset, you must first determine why the fuse blew up or why the circuit breaker opened. If the reason is overloading, then remove some appliances plugged into the same circuit. If not, then there must be a short circuit somewhere. Locate the short circuit and repair it at once. Most of all, don't forget to unplug the appliance or cut off the main switch when replacing a fuse. In addition to the danger of fire, a short circuit can electrocute you. Break in the insulation usually occur out of sight. For example, inside the metal casing of an electric stove here, or a table lamp, or even a refrigerator. Once the insulation is broken, the current will pass through the metal casing as well as through the wiring. Let us consider our diagram here. You have a refrigerator and there's a bare wire touching the casing. If you were to hold the metal casing of this refrigerator, you become part of the circuit. The current would go through you and you will act as the ground of the appliance. Perhaps you have already experienced this tingling sensation when you touch the metal casing of your appliance at home. A ground is a short circuit which is capable of handling all the current in the circuit. Grounding an appliance by allowing the current to go through your body sets up the condition needed for your electrocution. Now that's an electrifying experience none of us need, right, fellow teachers? Anyway, in order to provide some protection against unwanted ground connections, appliances with metal casing should be grounded, as indicated here. Makers of appliances with metal casing provide a third wire called the ground or the earth wire. The ground or the earth wire is a safety wire. It connects the metal casing of the appliance to the earth. This is how you should ground your appliance. Connect one end of the earth wire to the metal casing of the appliance, and then connect the other end of the earth wire to a metal pipe driven into your ground or to your water pipe. Grounding your appliance ensures that if anything goes wrong with the appliance that results in a direct connection between the live wire and the casing, the large amount of current would pass through the earth wire into the ground and not through you. For example, as illustrated here, you have an earth wire as a protective device, and so that if you touch the metal casing, then the large amount of current will pass along the earth wire to the ground and not through you. Now, fellow teachers, let's have a recap of the important points taken up in today's episode. A circuit whose wires carry more than the safe amount of current is overloaded. A circuit of very low resistance is called a short circuit. Overloading and short circuit set conditions for an immediate increase of current in the wiring. Extremely large current overheats the wire, which could possibly damage the appliance or cause fire. Fuse and circuit breakers are electrical protection that disconnect the circuit in the event an excessive surge of current occurs. A ground is a short circuit to the earth capable of handling all the currents in the circuit. Appliances with metal casing which are meant to be handled should be grounded properly. So there you are, fellow physics teachers. I hope today's episode has given you insights on practical applications of physics to our daily lives.